Hello everyone, welcome to my channel. Today I am back with a new lecture of basic circuits simulation. I will discuss today Kirchhoff's voltage law. What is a German scientist who proposed this law. Kirchhoff's voltage law states that the algebraic sum of potential rises and drops around a closed loop or path is zero. So Kirchhoff described that Kirchhoff proposed his law. Kirchhoff proved his law that in a series circuit, the potential rises across a circuit equals to the potential drop of that particular circuit of that particular resistors. Potential drop rises is equal to the potential drops. So this was the Kirchhoff's voltage law. He described that algebraic sum of the potential rises and drops around a closed path is zero. So if you add E, V1 and V2 according to their values and their signs, you will definitely get the result of zero. So in order to understand this circuit diagram, you must consider the two directions, either clockwise direction or anti-clockwise direction or counterclockwise direction, whatever you may call it. So I am using clockwise direction here. See that this is the potential rise. I am going to clockwise direction. Okay, clockwise direction here. So here you could see that this is potential rise. Here this is the DC source, DC power, whatever the source is. Here potential rises, potential comes. So this potential rises along this straight path. Here across this resistor potential drops, and some potential also goes straight forward to the next resistor. Across this resistor some all potentials have been dropped, and whatever potential is dropped is equal to that potential rises, that potential is given. So the summation of potential rise is equal to the summation of potential drops. If I gave 20 volt here, so some 10 volt drops here, 10 volt drops here, so 20 volt equals to 20 volts. Potential rise is equal to the potential drops. So this is the Kirchhoff's voltage law. In symbolical form we represented this sign summation V equals to 0. So these two concepts you must remember that. uh, okay, one thing I want to memorize is that this thing here we have to these we need the sum of that potentials plus E, potential rise, here potential drops minus V1, here another potential drops minus V2, and these are equal to the potential rise is equals to the potential drop. So symbolically we could see that summation of potential rises is equal to the summation of potential drops. So this was the basic law which Kirchhoff described, that potential rise is equal to the potential drops, and in other words we could easily summarize it that the algebraic sum of all the voltages around a closed path or around a loop is equals to 0. This is the law which Kirchhoff proposed. So now we are going to see the circuits, the basic design. of Kirchhoff's law to verify it with through a multisim simulator. So you must search multisim live, and where you click this search bar, and then you log in with your account, and then you find this page. So I am going to rename this circuit with KVL. So Kirchhoff's voltage law. First thing, I need the components of Kirchhoff voltage law. So what components we need? We need a power source, a DC source, VCC, okay, and resistors. I need two resistors, okay, resistor here, can overturn it, change the angle of that resistor, and one thing I want is that ground connection. So all the components are has been putted here, and now change the values of the components. So double click, okay, much better. I'm going to zoom it for much better view, okay. So this is the voltage source, and I'm going to rename it with E, okay. DC magnitude, so I'm going to select 20 volt, okay. Now I want to change this symbol with this, okay. This would be much better for understanding, okay. Voltage source connected, and so everything is done. Now drag the mouse over here and connect the circuit, connect the components with each other, okay. Connected, and okay, connected, and the last thing I want to connect is ground, okay. Ground is connected, everything is done. uh, I'm going to rename this A, B, okay. So sorry, okay. I have connected all the components according to the circuit diagram of Kirchhoff's voltage law, that is a series circuit, and this, so all the components is drawn in the multisim. So now all the components is drawn, and run the simulation. Before running the simulation, I want to just check the voltages across these resistors and across this, okay. Voltage over here, okay. Voltage over here, okay, and voltage over here, and everything is completed. And now just click this button, and you would get the simulation ready. So you must understand the theory of Kirchhoff's voltage law first. that Kirchhoff's voltage law states that the algebraic sum of potential rises is equal to the algebraic sum of potential drops. So what you observe here? You observe nothing. You could not you could not estimate the results with these readings. So just open your mind and try to configure the results. So this is potential rises. Here potential rises 20 volt, and this potential straightforward comes across through the resistor 1. Through the resistor 1, here some potential has been dropped. What potential has been dropped? What you observe here, 20 volt and 10 volt. Here 10 volt is dropped, and this 10 volt is also comes across this R2 resistor 2, where this 10 volt also dropped due to, because that 1 kilo ohm 1 kilo ohm, the resistor's value is same, so all the voltage rises here. That potential has been dropped through these resistor, so potential rises is equal to the potential drops. So this is what Kirchhoff's voltage law tells us that. So one simple definition is that if you understand in another definition, so that is the E. So E value is 20 volt. So this is V1. V1 value is 10 volt. 10 volt is dropped here. Also 10 volt is dropped here. So dropped means minus 10 volt, minus 10 volt. So 20 volt minus 10 volt minus 10 volt is equals to the 0. So this is Kirchhoff's voltage law. If you enjoy this lecture, then comment on the comment below and like on this lecture. Thank you everyone.